Okay guys, you'll have to bear with me here. We'll see if we can get this done quickly. This is 9.2 honors and 7.2 math 7, and we're understanding theoretical probability. Now, theoretical probability will be in this lesson, and then the next lesson, lesson 3, will be experimental probability. I'm going to define both of those here so you can compare and contrast them. All right? So our essential question is, how can you use the probability of an event to make a prediction? Now, what we're talking about is a favorable outcome. So what we would do is we put this in fraction form. Now remember, every fraction is a division problem, which turns it into a decimal, which we can then make into a percent. The percent probability, okay? And I'm going to make that a lot more clear here in a second with an example. So a number of favorable outcomes, this is something you'd want to write down. Total number of possible outcomes, okay? So for instance, here's my example. I have a coin. The two possible outcomes of flipping a coin are heads and tails. That means there are two possible outcomes. So that's your bottom, your denominator, two possible outcomes. We want heads. So that is only one possible outcome, heads, one possible favorable outcome. That means that it's 1 out of 2 that we would get heads, right? Or 50%. We know that if we divide 1 by 2, we get 0.5. We can move that decimal over 2 places, we get 50%. So that's what we're looking at. Now, we're going to talk about, and this may seem a little bit more complicated than it needs to be, so I'm going to make it as simple as possible, but I also want you to have something to write it down with, the difference between theoretical and experimental probability. Okay, so with theoretical probability, is the expected probability. In other words, if I flip a coin 100 times, okay guys, then I would expect, because there's only 2 outcomes, and just like we proved over there, it's a 50% possibility or probability, then I would get heads 50 times and I would get tails 50 times. Okay, that would be theoretical. Experimental means that we actually do the results. We perform an experiment and track the results. So I would flip a coin 100 times. I would track how many times heads came up and how many times tails came up. And then I would go through, and if I wanted heads, I would go through and put that in fraction form. So if I ended up getting, I'll show you real quick, 53 heads, I would put 53 over 100 because that's how many times we flip the coin, which would end up being a 53% probability, which would be an experimental probability instead of a theoretical probability. Okay? All right, so hopefully that makes a little sense. We have to actually perform an experiment for experimental probability. Theoretical probability is just based on, like I said, number of favorable outcomes over total number of possible outcomes. Okay, so let's look at this scenario where we're talking about theoretical probability. Okay, so this is Excel number 5. Okay, so what the scenario entails is we have people coming into a store, and based on the cards that they get, they're going to hand out cards to every single customer. Okay, and based on the number of cards they get, the number that's on the card will determine how much of a discount they get on their purchase. So in other words, they could get a 15% discount if they get an even number on their card. They can get a 30% discount if they get an odd number greater than 6 on their card. Okay? You have to think about that one, right? An odd number greater than 6. I'll go through and outline that so you can see it when we go through and calculate it. Okay? And then 25% discount goes to the rest of the customers. All right? So here's what we're looking at. First, let's look at the even number discounts. Okay, so the first thing you have to realize is, in this scenario, there are 400 cards given out. I found that out by going through and adding up all of these frequencies. When I add these all up, they equal 400. Okay, so that's the number that we're going to put on the bottom. That is the total number of possible outcomes. Okay, now what we do is then for the 15% off, we look at the even numbers. So in other words, I would look at 2, 4, 6, 8, and 10, and I would add up those numbers. So I'm going to do this and I'll erase it. So 2, 4, 6, 8, and 10. So I added up all of these numbers, all 5 of those numbers. And what I found out was there was 199 of those cards given out. So the theoretical probability here is 199 over 400. Okay? So, and the funny thing is, you know, it depends on whether the reason this is theoretical, guys, is because they don't know if they're going to have 400 customers. Okay? So they set it up this way, but they don't know if there'll be 400 customers that come in. All right? So then that becomes your probability. So this is approximately 50%, right? It's approximately a 50% probability that the customer is going to get a 15% discount. Okay. So the next one we go through, and it's a 30% discount, and it's odd numbers greater than 6. So I'm going to go through and I'm going to erase this so we can go through. And we did odd numbers greater than 6. So odd numbers greater than 6 is only 7 and 9. So what I did here was I added up the 38 and the 47. So we still are over 400. Notice that that stays the same. And what we found out was that there was 85. Now, in order to get a proper probability, we would go through and we would divide each of these by 5 to reduce it down. And what we find is that we get 17 over 80. And that's the actual amount they're looking for, is that 17 over 80. I did approximately 50% so you could see that, but it's 17 over 80 is the probability they're looking for in that, okay? All right, so the last one. We have a 25% discount for the rest of the customers, okay? So we used all the even, right? So this, what was it, even numbers. We used this, right? This, and this, okay? So the rest of the customers, okay, what I did was, instead of adding up these 3 that were left, I went through, I added these 2 together, which is 199 plus 85, which is 284 customers. Okay? I'm gonna erase that because I'm gonna subtract that number from 400. 284, because we know there was 400 customers, right? Or 400 cards. We subtract the 284, which is the total of these 2, the 15% discount and the 30% discount. And what we equal is 116 cards left. Now this 116 cards are what are going to get the 25% off. So I do 116 over 400, okay? And then what I found out is that I would divide this by 4 because we always want the lowest amount. And when I divided each one of these by 4, we get a final probability of 29 over 100. So that's your 29 over 100. This is your answer for the 17 over 80. And this is your answer for the 199 over 400. Okay? So, because that can't be reduced. So that's what we're looking at. There's a lot of math in this. It's not hard math, but because it's a lot of addition, subtraction, but it's where statistics starts. Okay, guys? So make sure you go through and look at this. Ask questions if you don't understand stuff, and I'll help you out.
All right.